Behavior of increment and decrement operators in Python. How do I use pre-increment/decrement operators, dash, just like in C++? Why does count run, but not change the value of the variable?
Is not an operator. It is two plus operators. The plus operator is the identity operator, which does nothing. Clarification, the plus and unary operators only work on numbers, but I presume that you wouldn't expect a hypothetical plus operator to work on strings. Parses as, which translates to who. You have to use the slightly longer plus equals operator to do what you want to do. I suspect the plus and operators were left out for consistency and simplicity. I don't know the exact argument Guido van Rossum gave for the decision, but I can imagine a few arguments. Simpler parsing. Technically, parsing plus count is ambiguous, as it could be plus, count, two unary plus operators, just as easily as it could be plus, count, one unary plus operator. It's not a significant syntactic ambiguity, but it does exist. Simpler language. Plus is nothing more than a synonym for plus equals 1. It was a shorthand invented because C compilers were stupid and didn't know how to optimize a plus equals 1 into the incorporated instruction most computers have. In this day of optimizing compilers and bytecode interpreted languages, adding operators to a language to allow programmers to optimize their code is usually frowned upon, especially in a language like Python that is designed to be consistent and readable. Confusing side effects. One common newbie error in languages with plus operators is mixing up the differences, both in precedence and in return value, between the pre- and post-increment/decrement operators, and Python likes to eliminate language gotchas. The precedence issues of pre/post increment in C are pretty hairy, and incredibly easy to mess up.
Python does not have pre- and post-increment operators. In Python, integers are immutable. That is, you can't change them. This is because the integer objects can be used under several names. Try this. A and B above are actually the same object. If you incremented A, you would also increment B. That's not what you want. So you have to reassign. Like this. Many C programmers who used Python wanted an increment operator, but that operator would look like it incremented the object, while it actually reassigns it. Therefore the equals and plus equals operators were added, to be shorter than the B equals B plus 1, while being clearer and more flexible than B plus plus, so most people will increment with. Which will reassign B to B plus 1. That is not an increment operator, because it does not increment B, it reassigns it. In short, Python behaves differently here, because it is not C, and is not a low-level wrapper around machine code, but a high-level dynamic language, where increments don't make sense, and also are not as necessary as in C, where you use them every time you have a loop, for example. While the others answers are correct insofar as they show what a mere plus usually does, namely, leave the number as it is, if it is 1, they are incomplete insofar as they don't explain what happens. To be exact, plus x evaluates to x dot underscore pos underscore, and plus x to x dot underscore pos underscore, dot underscore pos underscore. I could imagine a very weird class structure. Children, don't do this at home, like this.
Drive. Python does not have unary increment/decrement operators, /++. Instead, to increment a value, use more detail and gotchas. But be careful here. If you're coming from C, even this is different in Python. Python doesn't have variables in the sense that C does, instead Python uses names and objects, and in Python ints are immutable. So let's say you do What this means in Python is, create an object of type int having value 1 and bind the name a to it. The object is an instance of int having value 1, and the name a refers to it. The name a and the object to which it refers are distinct. Now let's say you do. Since ints are immutable, what happens here is as follows. Look up the object that a refers to. It is an int with id 0 by 559239 id 380. Look up the value of object 0 by 559239 id 380, it is 1. Add 1 to that value, 1 plus 1 equals 2. Create a new int object with value 2, it has object id 0 by 559239 id 3a0. Rebind the name a to this new object. Now a refers to object 0 by 559239 id 3a0 and the original object, 0 by 559239 id 380, is no longer referred to by the name a. If there aren't any other names referring to the original object, it will be garbage collected later. Give it a try yourself.
In Python 3.8+ you can do a lot of things with this. Or if you want, write something with more sophisticated syntax. The goal is not optimization. It will return 0 even if a doesn't exist without errors, and then we'll set it to 1.
If you want to support the channel, please consider subscribing.